Now we're going to take a look at a type of notation used with functions called simply function notation. To do that, we're going to go back to the mapping diagram of our superheroes and their secret identities. So again, we've got the x values, the superheroes on the left, and the y values, their secret identities, on the right. Now if we wanted to name the function that is taking Superman as an input and giving Clark Kent as an output, we might just call it the secret identity function. So that's going to be the name of this function. We're going to name it the secret identity function. So I've written the name here in the center. Now that allows us to write a statement like this. Y is equal to the secret identity of x. The values on the right are equal to the secret identities of the values on the left. You take the values on the left, Superman, you put it through the secret identity matching function, and you get an output, Clark Kent. Notice that we read this as secret identity of x. So when you see these brackets here in function notation, you read them as of. Also, these brackets don't mean multiplication. We're used to seeing brackets in math and thinking of multiplication because that's usually what they mean, but in function notation they have a different meaning. They simply are used to separate the input variable, x in this case, from the name of the function. So don't get confused by that. All right, so let's take a look at a specific example. In this case, Peter Parker is equal to the secret identity of Spider-Man. And what the statement down here means is if you take an input value, an x value of Spider-Man, you put it into the secret identity function, you will get an output of Peter Parker. So an input of Spider-Man goes into the secret identity function, shown like that, and you get an output of Peter Parker. Let's take a look at a more mathematical example. Here we've got some numbers. Now we're going to name this function f, which is a common name for functions in math because f stands for function. So if we match up the x values and the y values as shown with the arrows, and we call this function f, we could write a similar statement to the one we saw before. Now we write y is equal to f of x. Previously the function was named secret identity, now it's just named f. So this is the name of the function. It's not actually a variable like x and y, it's the name of the function. So we can now make statements like 3 is equal to f of negative 5. Again, when you see the brackets, you read that as of. You could also read it as at. So 3 is equal to f of negative 5. That means when you take an input of negative 5 and you apply the f function, which you do by following the arrows, you get an output of 3. Now, this down here asks us, what's f of 6? That means, what's the output of the function f when we feed it an input of 6? So here, if we feed the function f an input of 6, follow it along, you get an output of 4. So f of 6 is equal to 4. Okay, so this type of notation that we're using here is called function notation. And it's got 3 parts. It's got the name of the function, secret identity in this case. It's got the space for the input variable, which is usually x, and the space for the output variable, which is usually y. So we saw that secret identity of Batman was Bruce Wayne. Again, the name of the function, the input variable, and the output, or the input value, and the output value. So f of x is equal to y, and then we saw that f of 6 was equal to 4. So in black, I've written the names of the functions, f or secret identity. In red, you see the input variable or the input value, and in y, the output variable or the output value. Okay, so they've all got the same kind of format. And this is function notation. In the next video, we'll look at a couple of pointers, and then I will show you how this looks when you are looking at it on a graph.